Let's go ahead and go over our practice page about mixed numbers turning into improper fractions. As we go over this, feel free to correct or fix anything you may have missed. Let's go ahead and take a look at number 1. The mixed number 2 1/3 is the same as blank. Starting with my rectangular model, I'm going to draw 2 holes. And I'm going to recognize that since in my mixed number I have the fraction 1/3, all of my holes are made out of thirds. So I'm going to cut each hole into thirds. And my first hole is made out of 3/3. My second hole is made out of 3/3. Then I need to have one more third. So draw a hole, cut it into thirds, in one of those pieces. I can now easily count my thirds. 1, 2, 3, 4, 5, 6, 7. That gives me the improper fraction of 7/3. This can also be represented in an addition sentence. I have 2 holes that are made out of thirds. So that's 3/3 and another 3/3. Then I have 1/3 more. That gives me a total of 7/3. An optional method that you may choose to use is more of like an algorithm that your family and friends are probably going to be more familiar with. If I have 2 1/3, that means I have 2 groups of thirds. Look up here, 2 groups of thirds. That would be 6/3. And then I have one more third. That gives me a total of 7/3. Let's look at problem number 2. The mixed number 3 2/5 is the same as, again, I'm looking for an improper fraction. Let's start with a model. First, I'm going to draw 3 holes. And it's important when I'm working with those mixed numbers that I'm looking at the fraction part. And it says fifths. So that means all of my holes are made out of fifths. And for each hole, I have all 5/5. So I have one group of 5/5, 2 groups of 5/5, 3 groups of 5/5. Again, that's my 3 holes made out of fifths. Then I have 2/5 more. To make 2/5, I'm going to draw a hole, cut it into 5 equal pieces, and color in 2 of those. Now I can easily count all of my fifths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's going to give me 17/5. This can also be represented as an addition sentence. I have 3 holes split into fifths. So I have 1 hole with 5/5, 2 holes with 5/5, 3 holes with 5/5. And then I have 2/5 more. Now I can just add them together. 5, 10, 15, and 2 more would be 17/5. An optional method that you may choose to use is more of that algorithm that your family will be more familiar with. 3 2/5. I can see this as 3 groups of fifths. Again, here's my 3 groups of fifths, which is 15. And then I have 2 more fifths. So that's going to be 17/5. Let's look at our last problem, problem number 3. The mixed number 5 3/4. Starting with the whole number of 5, I'm going to start with 5 holes. Now in my mixed number, I'm going to look at my fraction part and see that my fraction is cut into fourths. So all my holes are created by fourths. And each hole, I'm going to color in 4 out of those 4 pieces. Then I have 3/4 more. Now I can easily count how many fourths there are. I'm going to skip count this time. 4, 8, 12, 16, 20, 21, 22, 23. That should be 23 fourths. This can also be represented as an addition sentence. I have 5 groups of 4/4. So I have 1 group of 4/4, 2 groups of 4/4, 3 groups of 4/4, 4 groups of 4/4, 5 groups of 4/4. Then I have that 3/4 more. I'm going to go ahead and skip count to quickly solve this. 4, 8, 12, 16, 20. And 3 more would be 23/4. An optional method you may have chosen to use is more of that algorithm. If I have 5 and 3/4, you can see it like this. 5 groups of fourths, 5 wholes made up of fourths. And here they are, 5 groups of fourths. That's 20. And then I have those 3 more fourths. So that's going to be 23/4. Again, our goal today is to be able to take a mixed number and change it into an improper fraction. You can use any of these methods. You just have to choose the one that works best for you.